So first, how would you factor this? What could you take out? S. So you'd be left with what? Right, S minus 2. If you wanted to solve, you would just set those both equal to 0. You would get S equals 0 and S equals 2. Okay? What about here? Right, you would have to do ACB. So you'd get 4 and negative 4. So you want to find two numbers that multiply to 4 and add up to negative 4. Any idea? The two values would be negative 2 and negative 2. So minus 2c, and then what do we do? Grouping, right. Put them in the boats. So I can take out a 2c, and you get 2c minus 1. And what do I have to take out of the second part? Not a 2, not a 1. Negative 1. So you get 2c minus 1, because remember, we need this to be the same as this. So you get 2c minus 1 squared. This here is also a perfect square trinomial. If you have something where your a term is squared, and your c term is squared, it could potentially be a perfect square trinomial. So if this is a minus, you just want to do the square root of the first term, so 2c, minus the square root of the last term, squared. So that's what we ended up getting. It's not going to work every time, but you can check that, okay? It's called a perfect square trinomial. All right. So, looking at this problem, how could we write this in factored form? What do both parts of this equation have? Sine x. So just like we factored out the s, we can factor out sine x. And what would you be left with? Very good. Any questions on that? So, look at this one. Look back to the warm-up. What is this? Perfect square trinomial. If you didn't know that, you could still do ACB. So let me show you how I approach these so I don't get overwhelmed. I changed the cosines to variables. So this would just be 4x squared minus 4x plus 1. And then I can look at it, and I'm basically using substitution. So I know x equals cosine x, okay? So now I would just do the ACB method again if I wanted to. But we know this is a perfect square trinomial, so I know I can just do 2x minus 1 squared. So the last thing you have to do is put cosine x back in for x. So you'd get 2 cosine x minus 1 squared. Mr. Rosen's being a little loud right now. All right, so again, now we have sine squared x and sine x. So I'm just going to make x equal to sine x. So I'd get 2x squared plus 3x plus 1. This isn't a perfect square trinomial because 2 isn't a perfect square. So I'm going to want to do the ACB method. So a times c is 2, b is 3. So what are two values that multiply to 2 add up to 3? Right, very good, 2 and 1. So 2x squared plus 2x plus x plus 1. And then we go ahead and make the boats factored by grouping. Who taught you that? Okay. So now we just do greatest common factor, 2x. Factor out a 1. So 2x plus 1, x plus 1. All right, so that's in factored form. And the last thing we have to do is just put sine x back in. So 2 sine x plus 1, sine x plus 1. All right, let's take a look at this. So I have secant squared minus 1 over secant x minus 1. Let's look at this. If I was to just put that as x squared, what is that? Does anyone know? What's that called? Difference of squares. Right. So x plus 1, x minus 1. So you can do the same thing with secant squared minus 1. I can make this secant x plus 1 secant x minus 1 over secant x minus 1. So now what's going to happen here? What's going to happen here? Right, they cancel, so you're left with just secant x plus 1. So you could have made this tangent squared x and gotten a common denominator down here and done all that, and you'd get the same answer. But you see how much easier it is if you can recognize that as a difference of squares? All right. So here's another one. This is what I'm talking about when I said like seeing the problem before it happens. This is the one case where you would want to make it bigger. You would want to make the problem bigger than it was. So what does sine squared x equal? Does anyone remember? 1 minus cosine squared x over 1 plus cosine x. So now what is in my numerator? What is that again? A difference of squares, right. So I can make that now 1 plus cosine x, 1 minus cosine x over 1 plus cosine x, and then they cancel, and you get 1 minus cosine x. Okay, so if you're able to recognize that this denominator is 1 plus cosine x, and you know that sine squared is 1 minus cosine squared x, that's a difference of squares, then you can do this. Again, if you were to just get a common denominator and multiply by the reciprocal, you'd get the same answer, but again, this is much easier. All right, so the last thing we're going to look at for today is something like this. Are these two trig functions the same? Is cosine the same as sine? No, so would I be able to factor something with two different variables? No. So what could I do to make them all one trig function? Any ideas? So cosine squared x equals 1 minus sine squared x. So we can substitute that. So 2 times 1 minus sine squared x minus 3 sine x. Okay? Then you would just distribute the 2. So 2 minus 2 sine squared x minus 3 sine x. Now you would just have to, reorganize this a little bit. So negative 2 sine squared x minus 3 sine x plus 2. If I was solving this problem, the first thing I would do is just factor out a negative 1, because I don't like to have my first term as a negative. So I would take this, take out a negative 1, so I'd have negative 1, 2 sine squared x plus 3 sine x minus 2. And then from here, you just factor. So you do the ACB method again. So we'd get negative 4 and 3. So two things that multiply to negative 4 and add up to 3. Close. 4 and negative 1, right. So then we'd continue. We'd get negative 1, 2 sine squared x plus 4 sine x minus sine x minus 2. Then we just have to group. Negative 1, we can factor out a 2 sine x. So you'd get sine x plus 2. And then here you just have to take out a negative 1, sine x plus 2. And then your final answer would be negative 1, 2 sine x minus 1, sine x plus 2. All right, so just real quick, if you were doing this, what would be the first step? What would be the first step for this problem? We have two different trig functions. Right, change cosine squared x to what? Right, 1 minus sine squared x. All right, and then you'd go through and factor again. You'd end up with negative sine squared x plus 2 sine x. 1 minus 2 is minus 1. Again, I'd factor out a negative 1, sine squared x minus 2 sine x plus 1. And then you would just factor. You'd end up with just sine x plus, yeah, thank you, minus sine x, sine squared x minus sine x. I was right the first time. Sine x minus 1 and sine x plus 1. I'm sorry, sine x minus 1. And that would be your final answer. All right, so this is the big thing I wanted you to get from that. I know you guys can figure out the factor.